welcome and welcome back. This is one of my flagship talk. This is one talk that I love to do because I think context prioritization and posture management is becoming more and more of a thing with the sea of problem that we have. And I think I love to describe this as we're trying to solve a 21st century problem with a 19th century's solution. CV, CWE, CVSS, and CWSS has been around for very, very long time. And we're still trying to shoehorn this in a very, very modern stack. And we're kind of overwhelmed and stuck in that. So I'm Francesco Cipollone. I'm the CEO and founder of Phoenix Security. We recently dropped the name AppSec because now we cover the full-blown context. And I have to give a warning that I make unhealthy use of memes during the presentation. I'll try to tone it down, but I always say security is such a gruesome work. It gives sometimes nice and warm feeling when you resolve things with a team, but a lot of the time it's a lot of grinding and a lot of, Christmas Day fixing log4j kind of thing. So I always say we can do that with a smile, and hence why my presentation always try to be on the funny side. As I said, I'm the CEO and founder of Phoenix Security. I've been around the block for quite a while on a lot of transformation from a cloud perspective, from an application security perspective. I've seen things failing, I've seen succeed, and that's a lot of the things that we embedded in Phoenix Security. And one of my main mission is to prevent burnout of analysts, security professional, and can we give back to those people, to us security folks, a more enjoyable journey on triaging, on fixing things, on getting ahead of the curve and not work like machines, but work like human. And that's a little bit the mission, and that's a little bit the journey that I'm going to walk you in this presentation. So we're going to see the problem and the problem changing and the changing landscape that we are right now, and how we can fundamentally get ahead of the curve of a lot of noise and a lot of alert, how we can bring order to the chaos situation where we are right now, with alert coming from every place. And my favorite quote is, not every critical is the same. And that's all about context. But if we try to treat fundamentally every critical as the same kind of critical, then we have a broken dream. Then we have a hope that we can get ahead of the curve without getting hurt. And the consequence of fundamentally shoehorning a 10 years old methodology, a 19 years old methodology into this modern landscape is that dev team don't want to follow stupid criticality rules. There are more CVE declared every day because there is more regulation around it. Software is hitting the world, so there is more software around it. And a lot of this software declared is static. It declared once and it declared critical, but the criticality actually changed over time, and only 10% of those vulnerabilities are actually exploitable. And the worst part of it is that security professional takes so long to get into these fields, but 50%, even more than 50%, are getting burnout, are getting exhausted, are considering even changing entirely career and getting into something else. And in the past year, we've seen a dramatic increase in terms of regulation around software security, vulnerability management. In the current year, we've seen more incidents happening due to these vulnerabilities. And this has clearly shown that CVE, CVSS is antiquated, is not there yet for this modern world, and will not be there for the year to come. And just to wrap up on this kind of data, because I'm a data-driven guy, so anything that I do is based on data. The CVE, as you can see, is spiraling up in terms of number of CVE declared. And just a little bit of a comparison. Back in the days, we used to have major kind of software panic or vulnerability panic that were quite apart from each other. And I took as a reference Apache Struts and Heartbleed as the main aha moment of major things happening that impacted the whole industry. Now, if we take it to this year, between Log4j, Spring4Shell, Node4j, Folina, and so on and so forth, we had major aha moments every 2 months. I think every security team is completely exhausted. And on top of that, we got a massive transformation due to COVID that led into a shortage between cloud and application security people and the demand of those roles piling up. And the situation is not getting any worse. You know, we get more CVE published every year, 35% in these particular years. You can see they're spiking up, and there is more regulation coming. So we'll see even more of this happening. And I think back in the days, we had Endpoint to fix and patch and Server to fix and patch. We still had software, but software wasn't as attacked as we know it today. While right now we have a very complex stack, and tracing who need to fix what and what is really critical, it's all a matter of context. Because otherwise, you have things that appears from vulnerability report, vulnerability scan. You have vulnerability scans on open source library or OSS, from code, from web and API dust, container security, and all the vulnerability reports that come from a container, cloud workload, and all the issue that you have on a cloud environment. And then the traditional application security, endpoint security. When you receive a report, who should fix it, where, and how important actually that report is. In this situation, it's almost considered impossible to look at things and decide what to fix first and what are attackers looking to attack right now. And even when we receive a threat intelligence report that there is this particular threat actor that is targeting this vulnerability, where is that vulnerability? Who is maintaining it? And how quickly can we solve it? So how about we do a little bit of a trivia? And this is my favorite way to engage the audiences. Today it's not very interactive because it's here. But traditionally I ask, between these two applications, as a gut feeling, where would you focus? If you had a noded list of software stack deployed on your container, deployed on your cloud, and the app on the left had 100 critical, while the app on the right had 10 critical. My gut feeling as a security professional would say, well, I focus on the one that has more density in terms of vulnerabilities. But the truth of the matter is, if the application on the left is a cafeteria app and the application on the right has business critical application or your payment gateway running on it or your main website, probably it's more important to contextualize vulnerability in that stack, focusing on those vulnerability first, doing an impact assessment, and understanding, can I fix it? And underlying, when you're trying to explain this in very technical term, you end up looking like that. You end up looking, the guy on the right, you end up looking like a crazy madman that is saying, you have this vulnerability on this web application that is running on this system, on this container. Business people don't understand that. And whenever you start talking in these kind of terms, they kind of disconnect. The challenge of this is they are the decision maker that are going to decide, well, we're going to dedicate sprint cycle, or we're going to sacrifice sprint cycle on fixing a problem or patching a vulnerability or upgrading a piece of code rather than deploying new feature. Now, we need to create a line between software engineers and organization, because as a defender, as a blue team, we are at a disadvantage because attacker need to find one vulnerability. We have to identify which of those vulnerabilities will attacker fix, and then deal with all the organizational politics. And we are, as a security professional, as a blue team, we are on a short staffed. And generally speaking, there is the ratio of 100 developer, 100 engineers to 1 security professional. It's actually sometimes much worse. And just implementing security champion program and just saying, you know, developer just go and fix, it's not going to cut it, because actually those fixes are not going to get implemented. You need to build a culture of understanding why vulnerability are bad. And even in that case, you need to still prioritize it. And there is this consistent battle between security and professional, and security that complain, please go and fix and patch things, and developers saying, I don't have the time. So how do we fix it? Well, the solution is risk and contextualization. The solution is getting ahead of the curve, focusing on what's more important, and focusing on really what risk matters, rather than focusing on all the problem all at the same time. So in this scenario, what I used to say is context is king, risk is queen, and vulnerability are three. When you have a specific vulnerability and you contextualize on the system where it runs, on how important it is for the business, on how exposed it is and how much attack vector they are, you actually create a narrative that people can relate into. And if you even translate that narrative into a risk perspective, then you have a line of communication with the business that describe all these technical elements in one number, in one level. And then the business can decide, yes, I'm happy to live with that risk right now, because the risk of not going to market, the risk of shutting down a system is much higher than the risk of running with a specific vulnerability. But let me run you through a couple of scenarios that actually bring this to life. It's all good and well to say, well, you have a vulnerability, you need to discuss and detect where it is. So let's take an example, the infamous Log4j. Even by looking at just one simple aspect of the contextual part of the risk, even by looking at where the Log4j is deployed, we see a lot of variation. We see a variation over time on how much and who is looking at what. And then if we overlay fundamentally the concept of location, we can start seeing how the risk level or the exploitability probability of Log4j can then change. So the blue line in this diagram describes EPSS data and the work that we've done with EPSS to actually understand how exploited or exploitable was Log4j from the beginning to the end. And if you see that there is a variation. There are people looking at Log4j, there were people looking at Log4j very actively at the very beginning, and then it quieted down, and then it went all the way up all over again. But then this mapped into, if a system is internal, if a system is external, that gives you another way to actually overlaying and understanding what is the probability of something to get exploited. And if you can see, if a system is external, it is the orange line, it's much more exploitable. If a system is exploited, is external, and people are actively looking at it, you almost reach 100% of exploitability, because it's very popular, it's external, it's very likely to get exploited. While if the system is more internal, it's less likely to get exploited. There are still attack vectors for it, but they're still less likely. So this probability of exploitation helps you focusing and contextualizing and prioritizing fundamentally your work and the work for your developer to actually start focusing and fixing the things that matters the most and that deliver more unit of economics, more value for the organization. And at the same time, if you start explaining in this term to developer, to the business, you start in slightly moving towards back of the Einstein, of the intelligence wise guy that explain even a very complex problem to a kid with very simple word, and less of a madman that look at all the correlation possible and trying to explain that complex context into a board. But no, the comparison really comes to life with locality when you bring in two vulnerabilities. Between those two vulnerabilities, one that is a highly exploited attack vector that is Log4j, and one that is less likely exploited but still dangerous kernel issue, and those are just two examples, which one would you look at in these two business applications? Well, let's consider the one on the left. There are two vulnerabilities. CVSS plays a good score in this because they're on the same system. They're both external, so the system is flat from a factor perspective. So CVSS makes sense in here. So I'll focus on the Log4j, that is the more exploitable. But now let's start looking at really repositioning CVSS into locality. Now, a system that is externally exposed, that is an actively high exploitable vulnerability, maintains a CVSS or is even bumped up to a higher CVSS score. While the Log4j actually get dampened down dramatically. So all of a sudden, a very highly popular vulnerability is less likely to get exploited than a system that is externally facing. This is the power of context. And if you explain in this word, it's much more likely for a development team to then listen to you and a business team to listen to this prioritization and get less burnout. Now, let's add another of important concepts that is in the business context. That is the business context. So how much is an application worth? What are your crown jewel? Between these two applications, if we take in consideration Log4j, a Log4j on a cafeteria application is my favorite kind of business application. And a payment system, even if the system is inside and not directly exposed over the web, still makes the business critical application more likely to exploit and more likely to cause more damage to the organization. So all this, from a human perspective, is easy to understand and correlate, but sometimes we just get a list of assets, a list of problems, completely uncontextualized, completely uncorrelated where the software runs or where the application or operating system runs. And it's impossible to then determine in this very long list of things that traditional security scanner spits out, which one you should focus on, which one is important. Now, let's wrap up with a scenario where we look at these two vulnerabilities inserting the concept of location. So you have a vulnerability that is external, vulnerability that is internal, and two business applications, one that is less critical, one that is more critical, one that has data from a customer perspective, one that has the menu that you really crave that specific day. Now, from a human perspective, I might be interested in the cafeteria, but from a business perspective, I might be interested in the impact that a particular vulnerability might cause to the business. So if we take the two vulnerability with the concept of context where they run, the Linux vulnerability, I'm just going to call it Linux vulnerability because it's easier, scores at a 7.1 with reprioritization, and Log4j scores 6.4. Now, if we take the concept of how important that application is, those vulnerabilities get dampened down of a percentage of an amount. Now, the same applies to a business critical application where the vulnerability get bumped up, and then it kind of get bumped down a little bit over the concept of how important is the business or where it is and where it is running. So from this list perspective, if you had a team that maintained both applications, you have a very neat ordered list of things to solve in order of priority, not priority for you as a security professional, not priority for the development team, but as a priority for the business and biggest bangs for bugs in terms of fixing which vulnerability first. So you start with 8.4, then go to the 8.2, and so on and so forth. So you have an ordered list that is ordered by risk level and impact level. This is the power of contextualization. This is the power of looking at things contextualized. And I'm just cutting the chase. Traditionally, I go through 4 or 5 other different examples. But this explains fundamentally what you have in a modern stack. So you could have Docker and container vulnerability. You can have cloud security vulnerability. You can have Git keys and other Git issues or other code issue vulnerability. You can have the Log4j, other software vulnerability. You have other vulnerability that is more operating system. And in all these numbers, where do you focus first? So the more complex the system becomes, the more it's difficult to do this analysis manually. And roughly, we estimated that a manual assessment is roughly around 9 hours on a full modern stack application if you don't have any way of automation. And traditionally between startups, SME, and enterprise, the time to actually fix or look at vulnerabilities, it goes from 40 minutes all the way down to 10 minutes per team, if you like. So the whole concept of contextualization is to focus and prioritize vulnerability, looking at things in a risk-based form and not looking like a madman. So this is the whole scope and conversation that I would like to have today, is how do we move into a conversation to address challenging answers. Looking at individual reports, you have chaos. And traditionally, if a business person asks you, is this application secure? The usual answer is, it depends. Let me look at things. Let me look at 4 scanners. Let me look at 4 reports. Let me talk with the developer. Let me see where they are with fixing these things. Without data, it's very hard to answer that question. And then if you try to answer that question and correlate things, you look like a madman. And you kind of lose trust. Now, if you're a risk person and somebody asks you, is this application secure? And you can answer, well, our application is currently within the risk appetite of the business where we operate. If there is more appetite in or less appetite in taking risk, we can fix more vulnerability. And this new vulnerability has come across. It is critical. It is on an external system. So maybe if you were to look at it, or maybe the risk exception that you recorded the other day has changed in value, has changed in criticality or in severity. So maybe let's reconsider it. You look like a badass. The problem is, from a software perspective, from a security perspective, we don't tend to talk about risk and quantification and risk management. So let's move to the second part, that is the 5-step process or 5-step program. That is, believe me, it's not a recovery program for alcoholic, but it's a 5-step process to actually, how do you get better at managing vulnerability across the board? How do you realize in a program this context and risk quantification? So I tend to categorize this as a 5-step process because it needs to describe the flow that you start by ingesting fundamental information, your asset register, aggregating vulnerability report from multiple sources into concept of business application, then mapping those business application into how the business runs and who maintains it. And with those information, you can then contextualize and prioritize the vulnerability based on where they run, who maintains it, and how important they are. And with that information, then you can move into the action part. Now you know where you stand, where you are, and you can move towards taking action, triaging, and acting on the vulnerability that matters more, or on the business critical application that matters more, and move into the act part. In this, you have a systemic circle that fundamentally enables you to move from pure guessing scenario in a chaotic environment in an ordered, machine-based, consistent way to fix vulnerability that matters more, that deliver more value. And in order to build fundamentally a modern risk scoring, the way to do this is to look at 4 aspects, because traditionally CVSS is based on one of those aspects, that is the severity, how bad it could potentially be, and it doesn't account for context, for business context. It doesn't account where the vulnerability is happening, how bad it is, how important is the system, and what is the probability of that event to happen right now. So if we break it down in simplest way and shape and form, we can look at a risk level to be the base severity of a CVSS to describe how bad in an embryonic form the vulnerability is, and then how exploitable, who is attacking what at a specific scenario, if there is a fix available, and where it is that vulnerability manifesting. That gives us the probability of exploitation. Even if you use one of those factors, leveraging EPSS, that is fundamentally the probability of exploitation, you're already much better off fixing vulnerability than where you were before with just CVSS. And then if you bring the impact analysis, how many users this vulnerability could affect and how important it is, the business application that this vulnerability affects, then you are really in the next generation of risk management that is taking into consideration how important is that specific asset for the business and how likely is that event to happen. And then you can have a very good conversation with the business owner saying, this risk level is outside tolerance, is outside risk level. Do you want to do something about this risk, or do you want to carry over risk? It's much more likely that you will get hurt. But in order to build some of these elements, you need to create the concept of business application. You need to correlate and contextualize things in this way. And if you look at individual elements of a modern business application built in the cloud, you'll go mad and you look like a madman. So how do we look more smart? The solution is correlation. So looking at the code that you buy or you build, that's your OSS or that's your build software, where you build it, correlate to where you run it. And this gives you the concept of locality, where the software runs and how likely is that to get exploited. And then if you want, you can layer on business context to actually understand how important is that particular business application that you build on the left. And then you can build in threat intelligence and link at specific IP address or CVE information. How likely is somebody to attack that vulnerability? So bringing in these four elements together enables you to create a modern risk scoring and expectation that you can then drive into action, that you can then decide to do or what to do. And then you can leverage fundamentally things in one domain or the other to actually build even more intelligence. Like from a cloud perspective, you'll never know who runs a specific system, but you might know who runs a specific software that runs on a specific container. And you can kind of infer, well, this team is more likely to get access to the Terraform script that has built that particular software. So having a concept or a cloud of knowledge enables you to correlate and contextualize and infer information from one domain to the other domain. So you can transfer information that traditionally live in software world, in ops world, specifically in cloud, this is particularly important, and the other way around. Threat intelligence traditionally lives in ops world, and in running an operation, you can transfer some of this information in software application and correlate and contextualize and transfer information across. So how do we prioritize and how do we focus on the 10% of vulnerability that matters most? How do we bring this to life? Well, as we explain, we need to focus on two aspects, the impact aspect and the exploitability aspect. That forms fundamentally what we call risk, and that's what we can take into consideration as reprioritization of CVSS. You can supercharge exploitability with things that I mentioned before, like cyber threat intelligence. Who is looking at specific vulnerability in this particular moment? Where it is this particular vulnerability manifesting, and based on that, what is the probability of exploitation and exploitability? And finally, you can get all esoteric and looking at who is chatting about this vulnerability with simple Twitter chatbot. And a lot of these information are open source and available out there. EPSS is the main piece of work that we are collaborating in bringing to life, because we believe that open cyber threat intelligence should be available to everybody. But then it's really important to map this to your own organization, because that's where locality and impact analysis really comes to life and really enable you to prioritize to the next level and to look like less of a madman and more of a professional. Now, the challenge is doing this manually is very challenging on one application. Doing this at scale is almost impossible. And trying to explain your current risk position with just number of vulnerability to a board, very difficult. So as I said, this is the traditional process that you operate on. And if you automate a number of those functions, then you can really focus on translating the risk message to a team, to a board. you really need to look at least 3 stack elements, that is software, cloud, container, infrastructure, to understand a little bit how and where software is run or built, where it is running, and then you can go into aggregating, contextualizing, deduplicating, and correlating. A lot of these things can be done manually, but it's extremely time consuming and burn you out. So if you have a system that can do this automatically, then you can focus on the part number 2 and 3, that is the risk assessment, going all the way to the threat assessment and translating this particularly complex message into a conversation and making sure that the various teams can then operate based on this risk level. And if you try to solve this manually, we're going to fail. There are 570 more developers than any security professional. And as I said, we are outnumbered and outgunned. If you want to do this at scale, you need to build automation into it, because it's simply not doable and it's simply not enjoyable anymore. Doing security mapping to up to 10 applications, 10 teams, how much time you can dedicate. If you're a startup, you have 100 developers, 2 security professionals, 48 minutes a week for each team. If you're into a mid-sized financial, you have less than 10 minutes to triage an application that is more likely have 100 containers and number of repositories. So it is almost impossible to do at scale. And what have we done to solve this problem at scale till now? SLA. We used SLA at scale to try to push teams to fix stuff. And security SLA is traditionally a timer that we try to impose to teams, to development team, to go and fix stuff in a specific amount of time. Now, this doesn't account what is more important, where it is manifesting, what is the business context, is there a change freeze? All these things actually create an enormous amount of frustration in development team that get bashed up across the organization to not fix fundamental things in a specific SLA. SLA are not the answer. SLA is an answer at a specific level of maturity. When you don't have anything, it's a rule that you can establish to say, I'll fix critical in X amount of days. When you start evolving a little bit more, maybe you can say, well, maybe critical vulnerability, I'll fix then in a specific amount of time. Maybe I focus on external system versus internal system, and external system have a time frame to fixing specific critical vulnerability in 2 days, while internal system maybe have 10 days. But then if you want really an advanced measure to fix SLAs, then you link it to a risk scoring, because the risk scoring has, in a modern risk scoring, has all this modern concept of where it is, how bad it is, where it is in the context, how impactful it is. And the last mile, you actually move away from SLA. The last maturity level and the metric that matters is you move into security OKR. You let team determine by themselves what is the scoring and the metrics that they want to maintain, as long as they maintain a risk level that is compatible with you and with what you decide with the business. And those metrics could be maintaining an X amount of mean time to resolution, or beneath a specific amount of mean time to resolution every month, or fixing X amount of vulnerability every week or every month. Those things can be agreed and discussed, but it needs that conversation to happen, and it needs a target that is, generally speaking, risk, to actually stimulate those kind of conversation. I don't want to bash up too much on SLA because it's a method, it's a system that works. So is CVSS. I just think that is, for this modern world, enormously antiquated, and we can do much better to get into a more enjoyable state. We put together back in the days a maturity evolution on metrics that really matters at various stages of maturity of an organization. And we use these to actually score a lot of the organization that we deal with and saying where you are and where you want to be, how mature you want to be. And traditionally, at a very low maturity level, where you don't have any concept of security scanner or vulnerability, you tend to find problem maybe on a pen test, on an occasional pen test, and the only scoring that you can really apply in this case is how many vulnerability you have, how many you want to fix. And that's appropriate for this kind of organization, because if you try to put any more structured metrics, you're going to fail. If you start putting risk-based and you don't have a system that actually support risk or SLA, what's the point? Sorry. When you start having scanner information, scanner in your pipeline, then you can move towards an SLA, then you can move towards a matrix. And when you start having more complex system or more complex vulnerability, you can then move to a multi-level resolution time for SLAs and have particular ticket that operates at criticality level or severity level, or even better at risk level, where you can have risk-based SLA that take into account multiple aspects. And then you move to OKR. So as a wrap up of all the conversation, we have the tool, there is a methodology, there are steps towards explaining things to both two teams in a more risk-based fashion. My usual recommendation is don't go out and try to find a tool that solves this from a technology perspective, because this is a combination of skill, technology, and process. Technology is there to aid and speed up the resolution, the risk remediation, and the process remediation, but you still need people that discuss with organization and go and fix things. Technology is only there to actually accelerate. So don't just go out and buy the latest tool. If I want to leave you with a message is act on risk and fix vulnerability, fix on the vulnerability that matters most. That's our mission, that's our motto. And with this talk, I hope you find the direction if you were lost in the sea of vulnerability. I would say with fixed security, we found a way to bring security in the 21st century, kind of. Definitely, we've given you a way to take measurement and take vulnerability management to the next level, to translate a very complex method to something that business and the rest of the board can understand. And look out there, because there is a lot of open source intelligence and information that you can already leverage on to improve the triaging. Work smart, not hard. And as a shameless plug, we actually believe in this, and we build a system that does exactly that, that fundamentally triage and operate at scale and help you accelerating faster and decide faster what to fix based on risk. If you're part of OWASP, we are a big OWASP lover and OWASP supporter, so you can get an intro version of the platform. And we've wrote a lot about these things. So we've wrote a book to actually how do you mature an organization from an application security perspective. This was a community edition book. We've wrote a lot about how to run vulnerability at scale, what are the metrics that matter, how to prioritize. A lot of the information that I shared here are detailed case by case, the risk level, it's detailed case by case in a couple of white paper. And recently we just published the metrics that matters, moving from SLA to OKR, all this discussion that we've done into a white paper that has taken us as a community 8 months to put together. So it's quite comprehensive, and I strongly recommend to go and have a look at it. So I'm gonna leave you with, there is a better path, there is a better way. We can do and fix vulnerability better. We just need to get through the journey and acting on risk, rather than staying in the 19th century. I talk a lot about security, and this is the last plug. We have a lot of this conversation as well in the podcast, so please feel free to listen, and I appreciate if you give us a like. I'd like to thank you everyone for your time and attention. I'm Francesco Cipollone, and the founder of Phoenix Security, and I'll open up to question. All right, guys, thank you so much. And then you can reach to me on LinkedIn, on social media. I'm at FrankSec, 42 on Twitter and Francesco Cipollone on LinkedIn. I think I have a slide on this. So you can reach out to me for more information about prioritization and vulnerability management. That's what we traditionally talk about. It was in the intro slide, so I can share back this one. If you scan the QR codes, you can ping me. And if you want to participate in also white paper and other contribution, we always accept contribution from the community. So thank you very much and have a great day. Stay safe out there.